topic, the whole topic, starting from booklet 1 to booklet 2. So we'll learn a new formula to calculate the radian of the angle. To find the angle, you just divide the arc length by the radius. That gives you the radiant. And to convert from radian to degree, you have to multiply by 180 over pi. And to go the other way, you times by pi over 180. Alright, so this is the rule for conversion. And they need to know these special values, which will help you in the long term. Remember this, pi on 4, pi on 3. Just remember, the 60 is the 3 in the denominator, the 30 is the 6 in the denominator. And then there's pi on 2, pi, 3 pi on 2, 2 pi. So you should memorize this. Need to memorize. Memorize. Okay, memorize. Okay, and then also there's more memorization. There's a lot of memorization that you need to do in this topic. So also these exact values needs to be known, like sine pi on 6, sine pi on 4, and sine pi on 3. That will be equal to root 3 on 2, 1 on root 2, and half. Okay, so remember this. Also the cos one as well. I won't write this down, so or you can just remember the order from the table. So that will be root 3 on 2, 1 on root 2, half, and then you get, what's the next one? 1 on root 3, 1 and root 3. Okay, so remember this. Alright, write them down. Okay, good. Once you do this, you need to know how to change your calculator to radian mode. So to do that, just press Shift, Mode, and then press, I think, option 3 or 4. So you do this. It's 4. Okay. Let's double check. Shift Mode, 4. Yep, and then degree is 3. 4. And then the other one you do Shift, Mode, 3. Okay, so do that. And we need to know how to solve a trigonometric equation. So there's an example for you to try. So you just move the x to the other side, 1 to the other side. Divide by 2, you get negative half. You look at which quadrant it is in. It's negative in the second and the third quadrant. Then you find the related angle, which you can do shift cos of positive half. Never do negative, just do positive half. And then on your calculator, so you can either do it in, you can do it in degree mode. So if you go shift cos 1 over 2, you get 60 degrees. Or if you do it in radian mode, you go shift mode in radiant. If you do that again, give you decimal, but if you divide by pi, it gives you 1/3, so pi over 3. Okay, so you do pi over 3. So you label pi over 3 there, label pi over 3 there, and you can find out what x is. So x in the second quadrant will be pi minus pi on 3. In the third quadrant, you do pi plus pi over 3. And then if you simplify, your answer will be 2 pi on 3 and 4 pi on 3. Of course, there's other type of question you need to know. Things like things with cos 2x equal to 1, so we have to change the angle, and also things with cos square x equal to 0.5, things like that, or 0.5. So these ones, just refer to the notes. How to solve this, refer to notes, okay. Alright, so other thing you need to know for this is you need to know general solution, which is on the reference sheet. So there's the sine. Let's solve this one as a general solution. So you go cos x equal to negative half, and then to get the general solution, you write x equal to 2n pi plus or minus cos inverse of negative half. Okay, actually, well, I don't need this. Need more space. Okay, alright, good. And then go back. Okay, so what you do is, for this one, you don't change to positive, you leave it as negative, and then use your calculator. So you do shift cos, maybe if you do it in degree mode, actually do it in radian mode, you get -1/2, because you will get exact value, over 2. You get this divided by pi, you get 2π/3. So this thing is 2π/3, plus or minus. And then write down where n is an integer. Okay, so we have solution that has a restricted domain and also the general solution. Note the differences between them, how to do them. Alright, so we've got equation, exact value, how to convert radian to degree, degree to radian. So these should be well known to you, and the exam will have questions on those, from easy to hard. Then we have to look at other aspect of this course, which is the arc length and area of the sector. These two are given to you. Arc length is r times theta, and sector will be, area is half r squared theta. These are all on the reference sheet. Now be careful, for these formulas to work, the theta has to be in radian. So, and then for the next one, you got the area of the segment. That's not on the formula sheet, but you can just remember it is sector subtract triangle. And when you remember this, you will do half r squared theta minus half r squared sine theta. Just do that. Okay. Alright, good. And then we have other questions. So these are extension 1, so I'll just put an extension 1 here. This is extension 1 only. Extension 1. So you just need to know 1, 1, 1. These are all 1. Okay, so if sine x over x, when x approaches 0, it's 1. If the numbers are the same, you have to match the numbers. They are 1 as well. It also works with reciprocal. Okay, you will get a question in that, for that in the exam as well. Alright, good. And then we'll do a simple example to illustrate how to do this. So it's very simple. It's very important that you show this work in your exam for you to get the full marks. So the first bit is you take the 4 out. So you take a quarter, limit x approaches 0, sine 3x over x. That's your first step. Okay? Even if you know the answer is 3/4, you still have to show the working. Otherwise, you may not get the full marks. Unless it's a multiple choice, you can write down the answer. Otherwise, you need to show working like this. Put a 3 at the bottom, put a 3 on the top, and then you have to write times by 3. And then what you do is, this equals to 1/4, or 3/4, times by 1. You have to write this is 1. This whole thing becomes 1. So the answer is 3/4. Okay? So you need to show this detail working. Alright, these are done. Okay, so then we're going to look at graph. Okay, so graph. So we need to know how to draw the graph of sine and cos and its transformation. A is the amplitude. Period is 2 pi over n over b. C is the vertical shift. Like that. And for tan, it's a bit different. The period is pi over b instead of 2 pi, and c is also a vertical shift. Alright, and then do I have examples? So again, you look at the notes for detail how to do these questions. What else are there? Differentiation of the 6 trigonometric functions. Some of these are on the formula sheet. I think just these 3 are on the formula sheet. These 3 are not, so you should memorize them. So derivative sine is cos. Derivative cos is negative sine. Derivative tan is sec squared. Okay, you should know this off by heart, but remember they are on the reference sheet. And the other 3 are not on the reference sheet, so you should know how to do this. So sec x tan x. Because it's not on the reference sheet, question can ask you how to do that, how to differentiate. Okay. Actually, I will maybe talk about it later on. Okay. So, okay, let's move on to the next one. Cot is very similar to tan. It's negative cosec square. And this is very similar to above. Negative cosec x, cot x. So all you have to do to know the other two, just remember if there's a co here, put a co in front. If there's a co here, put a co in front. And put an extra minus. Right? So if you know the one above, you will know these two. Okay? Alright, good. So let's move on. Actually, while I remember, I just need to tell you. Okay. Let's do this. Okay, yeah. Now, if you go back to which page? Yeah, this page. You need to know how to differentiate using the result, how to derive, how to. That's on page 8. So go to page 8. Hopefully the teacher has derived with you how to derive sec x. So what you need to do, just write sec x as sec x equal to 1 over cos x, which is equal to cos x power negative 1. So you can differentiate it using the chain rule. So d over dx, sec x equal to, bring the negative 1 down, power negative 2 on page 8, times by, so have a look at how it's done. So differentiate cos x is negative 2, and then you times by derivative cos, which is negative sine. And then double negative become cancel. You get 1 over cos x squared times by sine x. And how do I simplify? You just write that as 1 over cos x times by sine x over cos x, because cos square x is cos x times cos x. And you notice that the first bit is sec x, the second bit is tan x. So note its derivation. And you should note this derivation for that could be examinable. Okay, so I need to know how to do it and also know the formula. Alright, good. So the teacher did it with you? Yes? Yep, okay, good. So have a look at it. Let's go back to the revision. We'll go back to page 25. Okay, all the graphs should be known. Let's look at the graph again. Sine x. So 0, pi on 2, pi, 3 pi on 2, 2 pi. Label this for each question. So we're on page 25 now. Alright, do this. And the sine graph is going upwards. Like that. And then we got the cos graph. Okay, draw both of these. And then you got the cot graph, tan graph. Tan graph is 1, 0, negative 1. So for all of these, label this. Maybe I should have given it to you. Then you have to do it all. 3 pi on 2. So the asymptote, let's do it. Green. Asymptote at 90 degrees to 70 degrees. And then the graph will be drawn like this. Like that, okay. Oh, which is, you can just copy this one. Alright, that's drawn for you. Alright, so I'll just let you catch up a bit. And then see if you can finish the rest, because it's something you've done before. Okay, have a try. And then there's the reciprocal one, which we'll do in a minute. Alright, good. Okay, good. Let's and then there's the reciprocal one. So the reciprocal one works like this. Every time there's an x-intercept, there's a vertical asymptote. Vertical asymptote, like that. And then the graph will go the other way. Actually, I'll use a green pen. So you're going to go down 0, down 0. Okay. At pi 0, pi over 2, pi 3 pi 2, 2 pi. Okay. So the cot graph, and there's also the sec x and cosec x. Okay, use the green pen. Okay, let's try the sec x and cosec x. Sec x, again, every time there's a 0, asymptote, asymptote, and then you just go like this, go the opposite way. Alright, it's a reciprocal of cos. Sec is reciprocal cos. I drew the cos graph. Okay, and then same thing here. And then you get like this. Alright, good. So all the graph is drawn for you. You just need to know what the shape is, I think, just in case. Yep. Yeah, yeah. Continue. We just go like this. 2 pi, pi on 2, 3 pi over 2, 0. Okay, good. All done. All 6 graphs are done, and all the graphs are done, including its reciprocal. Notice that I include the derivative there for a reason, so please write down the derivative. We just prove the derivative. So write down the derivative for all 6 functions, and we'll try to relate that to the graph. So derivative sec is sec x tan x, and this is negative cosec x cot x, and this is negative cosec square x, whereas this is sec square x, and then this is just cos x, this is negative sin x. Alright, let's put it on one full page. Would it work? That would be too small, isn't it? Anyway, actually you can see all 3. I'll write them all down. And hopefully you see some pattern. And the way I rearrange the graph into 6 graphs on one page. Can anyone see any pattern there about the derivative and the graph? And yeah, okay. Anyone? Notice that I put all the negative derivative on the right, isn't it? Right? They all have negative. And what else are there? When does negative occur? When there is a co in front. See, there's a co, you get negative. There's a co, negative. There's a cosec, you get negative. And how does that relate to the graph? Every time there's a co, means that the graph is decreasing in the first quadrant. See, it's going downward. It's decreasing. That's why it's negative. It's decreasing here. That's why there's a negative. It's decreasing there in the first quadrant. So whenever the graph decreases in the first quadrant, you will see there's a negative in front of the derivative. Okay? Whereas the other one, sine, tan, and sec, it's all positive in the first quadrant, isn't it? The graph is going up. That's why there's no negative. So that's another way to remember the graph and the derivative and the formula. Alright, good. After we do this, we can then look at other things. What else are there? All the integration. So we've done derivative, we've done graph, now we'll do integration. So this is a huge topic, a lot of things. So make sure you know this one well. Alright, let's move on to the next bit. Okay, we just did that yesterday. Let's do that again. So remember some of the formulas. So write down cos square, sine square theta, sine square x equal to 1 minus cos 2x over 2 dx. Okay, and then you just go half in front, 1 minus cos 2x dx, like that, and then that will be half x minus half sine 2x. Okay, like this. Or you can expand. Half x minus a quarter sine 2x plus c. Okay, try the same thing with the other one. Cos square x. Okay, good. Next one, you get this one. You get 1 plus cos 2x over 2 dx, which is half integral 1 plus cos 2x dx, which is half x plus half sine 2x plus c, which is half x plus a quarter sine 2x plus c. Right, so you need to show this step in the exam, not to say try to memorize the formula for the integral of cos square x dx. You should show this derivation, and the answer will be slightly different if the x is changed to 2x or 3x. You still use the same way, but you'll find that the answer will not be identical. Okay, so all of this, and also need to know how to integrate tan and cot. We did that yesterday, and also sec square. I need to integrate sec square and cosec square. That's easy, just tan x. And to remember, just a co has the effect of giving you an extra negative, so write negative cot x plus c. And you can see in detail how I get the answer. See page, what page would it be? We did that last time. See page 18 for detail. Alright, and also there is tan square x. Now tan square x, you have to write that as sec square x minus 1 dx. Then you write tan x minus x plus c. Like that. Okay, like this. The other one, you should change the cos square. Actually, cos square is, what's cos square? Cos square is cosec square x minus 1 dx, and we just did cosec square, that's equal to negative cot. So we write negative cot x minus x plus c. Yeah. Alright, good. And turn over to next page, you'll get more integral. So work this out. Alright, good. All done. Next page, you will find that more integral. Sin x, it's negative cos. Cos x is positive sine. Tan, you have to write it as a fraction. Sine over cos. And then what you need to do is put a negative in front of sine, because the derivative cos is negative sine. So you get negative ln cos x. That. And cot is just sine over cos over sine, which is easier, which is ln of the denominator. Okay. Page 19. Alright, good. And then these two, sec x tan x is sec x. Just remember, you want to differentiate sec x, you get sec x tan x. That's how I got the answer. Okay? And this one is just become negative cosec x. And how do I know that? Just refer to page 19 for detail. all done. And then after all the integrations, you can fill out the next 2 pages of all the formulas that you know for this topic. I think trigonometry is the only topic has lots of formula. So make sure you memorize them all. Only as few are on a formula sheet. So memorize all the formulas. So fill out page 28, 29. Okay, hopefully it's all done, so you can just fill out the next page. Just treat it as a test, see how many formulas you remember, right? And if you want the answers, check booklet 1. Okay, so the next 2 pages is exact copy of booklet 1 work. If I look at booklet 1, so what page on booklet 1? We did that on... Yeah, it's on page 11 and page 12. Okay, just refer to, so do that as a test, see how much you remember. Refer to page 11 and the other one, page 12. Refer to page 12 of booklet 1. Booklet 1. And then see if you get them all right. If you didn't get them all right, make sure you try to memorize them. Booklet 1. Okay? I think that's all. And then you can do the chapter review after you finish